Hello, we are Group 4. Our group members are Ryan, Nicole, Chetan, and Allen. And this is our demo of Project 2, the benchmarking machine learning mobile application. The purpose of this project is to develop an application that uses the concepts of machine learning algorithms and a Java-based machine learning classification library called Weka. We are using the ozone dataset from the University of California, Irvine repository and storing it on the mobile SD card. Here's a demo of how the application works. We use the Weka library to implement the classifiers. Weka requires the file to be in a certain format, an ARFF type. We downloaded the original source data from the UCI repository and converted it into a .arff file. We chose the ozone layer detection dataset. Using this ozone layer data detection set, we try to predict if a particular day is ozone day or not. Ozone days are when high levels of ozone are formed near the ground level. When the ozone reaches a threshold deemed unhealthy for long-term exposure, local air quality agencies send out an ozone action or alert day message. Now we'll talk about a little bit more about the dataset. Inside the dataset file, it has a header section containing information about the attributes of the dataset. The last attribute is the class type, which is binary in our case. The remaining portion of the dataset beneath the data is the simple comma-separated values. And now we'll proceed to learn about the implementation with Genie.
Alright, let's go into more implementation details now. The user will select a classifier from the following list: random forest, k nearest neighbors, or naive Bayes. For this demo, let's select naive Bayes. Next, the user will input in a numerical value from 1 through 99, which represents the percentage of data to be used for training. Let's put it at 65% for now. The remaining 35% will be used for testing. Once the user presses the submit button, the dataset file and the parameters like the selected algorithm and the testing percentage are transferred to the cloud server for training of the classifier. In regards to the training dataset, the model is trained on an AWS server. Now, Nicole will be explaining more about the generated model file.
Alright, so here's a list of the models generated on our previous test runs here on the AWS server. And here is the new model that we have just generated. We use the classifier name and the training percentage to name these model files. Once it's trained, AWS sends the model back to our client mobile application to validate the generated model on the testing dataset. After the model is run on the test data, all the results are printed onto the application display. These are the same results that are saved in the log file. The main screen displays the statistics of the latest run. The application shows when it was executed, the selected classifier, the percentage of training and testing, the true acceptance rate, the true reject rate, false acceptance rate, the false reject rate, the HTER, and the complete execution time for training and testing.
The user can continue to try the same algorithm or different algorithm with the same or different data partition value. All the results are dumped and saved in a log file, which is stored on the mobile SD card. The user can click on the View Log button. This will change the display into a scroll view, which allows the users to view all past results. The future work includes adding a multi-threading feature to speed up the execution. We are also planning to create a UI that allows the user to compare results between different classifiers.
So, if you have any questions related to implementation of this application, feel free to leave a comment down below. Thanks for watching. We hope you enjoyed it.